Snap circuits are a great way to learn electronics. A lot better than many of these other modules they try and sell you, because you're using the actual individual components. Well, I wanted to see if I could make my own, so I did. I used these snaps that I found at the Michael's craft store and 3D printed my own LED snap circuit. I'll show you how I did it on today's Filament Friday. Filament Friday is brought to you every week thanks to the generous donations of my Patreon supporters. Please consider donating $1 a month to help keep it going. I found this snap circuit design by user Brian and Amy on Thingiverse, but after I printed it, I decided I just wanted to design my own. I found these 12mm snaps that work perfect with the snap circuit, so these will be the basis for my design. I opened up Tinkercad to begin the design, and I brought in a cylinder, and this will be the edge of the actual snap circuit device. And it's 22mm in width, so I just made the cylinder 22mm in diameter. Now what I want to do is bring the ruler tool and make that right at the center of the cylinder, so everything will work off the center dimension. And in zooming in here, I think I just got rid of the ruler, so let me bring the ruler back in, and I'm going to put it right on the line. And then I'm going to use if you click on the arrow of the ruler, you can set it to midpoint instead of the edge. So I did midpoint, and then I could adjust that cylinder so it was right at 0. And then I duplicated that cylinder, and now because it's midpoint, I can just adjust the distance to exactly 56mm. So center to center, they're 56mm. That's the advantage of using that midpoint. So now I bring in a block to complete this guy. And this needs to be 22mm wide, so it matches up, and then I just need to move the block up so they're even with each other. And the block is, because I've got the ruler set to the center, it's easy to see that the block is right at the center of this guy. So now I need to extend this out, and I did a 50 and then realized I should have done 56 because it's 56 center to center, so I changed it to 56, slide the block down, and it's perfect, center to center. So this looks good. Now I just need to group these guys together and make it thinner. And in this case I chose 5mm. I think the actual parts are 6mm, but this one's going to work at 5mm. And there I had the base that I needed to work with. So the next step was to make the recessed holes for the snap to fit into. And I measured a larger snap, and it was slightly smaller than 13mm. So I brought another cylinder, made a 13mm hole, moved it into close to the center of that other cylinder, and then I wanted to align those two, but by mistake I grabbed the block. I don't want the block. I don't want to center to that. So I need to go back and just grab the two cylinder pieces here and then just align those two so they're centered to each other. Now I need to recess or lift this thing up so there's like a 2mm wall underneath where the snap is. So I clicked on the arrow for the ruler again and changed it back to corner rather than midpoint. And then I lifted that hole 2mm off the base. So now I'll have a 2mm flat solid underneath it. And then I made a duplicate of it and went back to the midpoint setting on the ruler so I could just set it to 56. And now it's perfectly centered at the other cylinder. Everything's cool. So I don't have to screw around with anything. So the next step was to make the hole that goes all the way through for the locking mechanism. And that needed to be a 4mm hole, so I just made a cylinder 4mm in diameter, dropped it down, made it into a hole, and again, this one needs to be centered to those other two cylinders. So I just grabbed the hole and both of the holes and centered, and everything looked good. So the next step was to duplicate that, and because we're on the midpoint, I can just do the 56mm thing again, and boom, I got it. They're all together, and I'll just group this together, and I've got my base for my snap circuit. Now I needed to add a channel between the two snaps, and that's where the wiring will connect to the snaps from the component that will actually be on the other side. So I brought in a box and made it 4mm wide, and I just stretched it so it went all the way from recessed hole to recessed hole. And then I used the midpoint here to offset it 2mm so it would be flush with those guys. And then I aligned it to the center of the two blocks, and once I've got it aligned in both the X and Y direction, then these things can be grouped together and I'll have my channel. So there it's aligned in the X and the Y. Now I'll just grab all these and group them together. And there it is. There's the channel. And you can see it's the exact same height as the snaps. So it's a nice perfect channel. So now I needed to make 2 holes for the component to stick through. Okay, I'm going to put an LED on this guy. So I made it 2 millimeters in diameter, brought it into the channel, and dropped it down in. And then this is going to be made into a hole. So cut a hole all the way through so the wiring come through. So I made it into a hole, and then I duplicated that guy and just slid a new one to the left and held the shift key so they're in line. And it really didn't matter how far apart they were, because what I'm going to do is grab both of them, make them a group, and then center that group to the whole platform. So I grab everything, and then I just click align, and then center to the whole platform, and boom, they're automatically centered. And the spacing, I can bend the component to fit. So I just need to group these guys together, and I'm pretty much done. So we'll group them together, and you can see there's 4 holes, 2 for the snap and 2 for the component. So the next step was to export this as a .stl file and send it to Simplified 3D. So here it is in Simplified 3D on the Flashforge Dreamer platform, which I'm going to print this on. And I click on Edit Process Settings. Now I had used ABS on a previous design, so I need to change this to my PLA setting for the Flashforge Dreamer. And when I do that, you'll see it changes from right extruder to left extruder. So the left extruder is where I've got the PLA loaded. So the left extruder is now going to be selected for everything. Layer height, I'm going to use a 0.2 on this. No additions. I don't need a skirt or raft. 50% infill. No support. Temperature-wise, 200 degrees for the filament, 60 degrees for the bed, and I am enabling cooling, and I'm going to print at just 50 millimeters per second to give me a good quality print. And then clicked on Print Preview, and boom, it's ready to go. It said it would only take just under 30 minutes and just under 2 meters of plastic. So I sent it to my Flashforge Dreamer. While that's printing, I need to do some work on the snaps. Now these snaps were not designed to go together the way I'm using it. So I need to grind down this locking mechanism so it's a really, really small knurl on the end. So it'll go into the larger snap. So to do that, I got a little metal machinist screwdriver, and this thing will spin on it. So then I put it next to my grinder and just let it spin and slowly take material away. And as it ground, it just slowly got smaller and smaller. And it's going to keep going until it's the same size as this screwdriver, which was really a perfect fit. And there it is. So now I've got the locking mechanism, the pin that'll go through, and it's going to fit inside the snap. So I put it back in the screwdriver, brought the snap in, the large snap, and then just pushed it in until it snapped inside of it. And this is the actual rivet, so to speak, that's going to lock these two guys together. And this isn't the way these snaps normally work, but this is the trick to get these two to go together. So once I had that into the plastic, it looked like everything was fitting. I just need to line it up and then push it through with the screwdriver. So that hole I made, that 13 millimeter hole, was like perfect size. It holds the snap in place while I do this. So now there's a little tool that comes with these snaps for punching them together. And I put it into one side, clamped it in my vise, and then used the other tool that goes over the little nub snap, the top, and slipped it in and then put it over the piece that we just ground. And then when I hit this with a hammer, it's going to crush that inside the snap and basically, like a rivet, pinch these two guys together. And there it is. After a couple of hammer hits, I pull the tool off, and I've got my two-sided snap. Now the only thing I screwed up, I didn't put the diode in, the LED in place. So I had to come in here and push it underneath the snap. So I'm going to do the other side now with the wire already in place. And that LED, I just bent the wires and it just poked through the hole. So it wasn't much to show you there. But you can see this lines up perfectly with an existing snap circuit. So I'm not going to show you all the steps again. I lined everything up the same way I did before. I just need to hit it with a hammer again. And this time I'm actually pinching the LED wire between them. So 4 hits here, and this thing, I could tell it was solid. So just take the tools off again, and I basically have my snap circuit design. But I wasn't real happy with the connections. When I played with them a little bit, it looked like they could be intermittent or loose. But the snaps were working here. If you look, both top and bottom work with the SnapCircuit, existing SnapCircuit. So what I decided to do is just add a little bit of solder to each side. And these snaps are like tinned, so they solder really easy. So I just got my soldering iron in there, ran a bead of solder, and I just heated up the snap until it flowed. And I didn't want to go too much because I didn't want to melt the plastic, but it didn't take much at all. It flowed right into these guys, and now I had a really good connection. So once that was done, now I needed to mark it. I needed to put a label on it. So I got a silver marking pen, and I drew the LED symbol in the proper direction so I knew how to hook this guy up. And then once I did that, I realized, well, I need the LED symbol, so I added the two little arrows that turns a diode symbol into an LED. And there you have it, a SnapCircuit with label. So now the real test, will it actually work? So I got out some of my SnapCircuits, and I used a 3-volt power pack, a 100-ohm resistor, a momentary switch, and then my LED. Now you can get SnapCircuit LEDs. I did an LED so it's easy to demonstrate this, that it works or doesn't work. Then I used these 3 snap size connectors to connect everything to complete the circuit. And then once that was done, it was time to test it. And look at this. It works. Every time I press the switch, the LED lights. So success. So this turned out great. And getting those snaps to fit properly, well, that took several attempts, but I figured it out. So there's so many little devices that SnapCircuits doesn't offer that I can now make platforms for. Custom platforms, 3-prong, 4-prong, even 8 prongs, and put a microcontroller at the center of it. These things are awesome for teaching electronics, and they're great for anybody that's trying to learn, from kids ages 8 to 60. They're awesome. But this was a lot of fun for me. So if you like what I'm doing here, maybe check out some of my other project videos of what I've done with 3D printing and some electronics. And if you want to help support the channel, $1 a month to my Patreon, just click on that link there. It really helps out. And if you're not a subscriber, please click on the logo down here and at least subscribe. That helps a lot. So that's it for this week. I'll see you next time on Filament Friday.